I'm Danny Rajan Jacob, and I'm here to conduct a video presentation. It is based on the subject of fundamentals of programming in CPP, and it is a learning beyond LP video presentation on the topic fundamentals, functions and object oriented programming. So we have an introduction of what CPP is, which is what its origin created by John Stroustrup in 1979. And this presentation mainly focuses on functions and its uses application in real life scenarios, along with some concepts of OOPs like abstraction, encapsulation, etc. First, let's have a look what are functions. A function is to be defined as a block of code that performs a specific tasks. So it's simply a set of code that is used that comes under a function name, and that is used to perform that particular set of code when that function is to be used. And syntax is, for those who don't know what syntax is, a syntax is the way of writing code on the base for acquiring a specific task uh, based on the programming languages. But in CPP, the syntax of function is given below. The first is a return type, whether it's an integer type or a string type, character type. Then we have the function name. For while naming the function, there are certain rules to be followed, like it should not contain any spaces, it should not be a keywords or function or inbuilt function names. Then we have the parameter list or the arguments which are which may or may not be given by the user. We have also an example which is called add, the function name, and of which is of integer type, and two parameters a and b are also inserted. Then while declaring a function, we need to give a semicolon. If we are declaring and defining a semicolon, then we use the curly braces, and the semicolon is not necessary. That's the only difference between the syntax. Then functions are vital for achieving code modularity, which is design principle. So here are some of the reasons why function are important for code modularity. Because the first reason is because it's code reusability. Then we also have an example of it, which is double calculate area. The calculate area is the function name, and the parameter is the radius, and it is a program that is used to calculate the area of a circle. So 3.141 is the value of pi, and we also have a return value, which is used to return a particular value at the end of the function. Then the second feature is that it is the simplification of complex problems, that it usually breaks down complex tasks into simpler ones. Then the third feature is the improved readability with the help of encapsulating the functions and calling the functions. Then we have easier maintenance is one of the features of functions. Then testing and debugging is nothing else but the phenomenon of checking if the function is apt or working and making any changes accordingly. Then we have the next feature, or the next aspect, which is the working of a function. So a function mainly works in the form that it is having a return value, or it's a return type, and moreover its function name. In this case, it's heading, that is the function name, and is of integer type, and parameters if necessary. Here we have specified as void in the brackets, which is also not necessary, and the code will get executed if it's left blank, because it would become a uh, default parameter or default function without any parameters being passed. That too is possible. Then we have types of functions in CPP. So functions can be classified on various bases. Based on the function definition, the function can be classified as user defined functions, which is the functions which are defined by the user itself, and that is used to perform a specific task. for example the integer add in that program. Then user defined functions, sorry, library functions are the functions that are present within the within a CPP program. For example, in string.h or iostream.h, these contain function libraries that are inbuilt within the system itself. Then on the basis of return type, we have void functions are functions that do not return any value, and it does not have any return statement written within the function code. And the value returning functions, that are the functions that do return a value, and it is also return having a return statement within the code. Then based on parameters, we have parameterized and non-parameterized functions. The parameterized functions are the ones that are used to accept arguments as input. In this case, as the example, we have given the parameters as a and b, and the sum of a and b is the return value. And non-parameterized functions, we used do not use any parameters in between, that's why there is nothing within the brackets. Then we have, based on the scope, we have global functions. These are the functions that are used to operate outside a particular class. I will tell you what a class is in the upcoming slides. But to be brief, a class is nothing else but a way that is used to group a set of functions called member functions and variables called member variables or member objects, and they're together called as class objects. The functions that do not come under such classes are called global functions. Then we have member functions. These are the functions that are seen within a class, and it is a member of that particular class. In this program, the class name is my class, and the function member function is the void show, which is given in the second line. Then we have inline functions are nothing but the functions that are used to be executed at the time of its definition, and it does not need to be called again. It is used to save time, and moreover it is used along with the inline keyword within along with the function. So for those who don't understand what an inline function is, I have already given a difference between a normal function and inline function. This is the main difference. As you could see, in the inline function, the function body and the call is taking place simultaneously, and hence saving time, whereas in the normal function, the function has to be called after defining it again. There is some time being wasted there. Then we have static functions. These are the functions that is also used with static, that is used to access static members of a program, or of a class, or mainly used along with the class. Such functions are called static functions. Then we have an example program on functions that is to convert temperature in Fahrenheit to Celsius. Here we have the functions, the two functions that we have defined is Celsius to Fahrenheit and Fahrenheit to Celsius, for converting the temperature from either way. It is also having return statements, and we have two other variables being declared, choice and temp. And if the choice is 1, then the temperature would be converted from Celsius to Fahrenheit. Else if it's 2, it would be from Fahrenheit to Celsius. Else if it's other choices, then the program would be terminated. That's the main intention of the program. Then we have the next concept called object oriented programming in CPP. So this is the brief definition of what an OOP is. It mainly consists of the concepts that I have already told you in words like classes, abstraction, and so on. Then here are some of the concepts: classes and objects. So like I said, what a class is: a class is simply a method that is used to group functions and variables as objects, or called class objects. And coming to that, is object is what an object is. An object is simply an instance of a class that uses the structure defined by the class. So that's what an object is. Then we have an example program for what a class is. So this is the in this program, in the third line, we have bank account. That is the class name. It is used along with the class keyword. It is, and please note the two Please note the two words private and public. They are simply access specifiers that are used to determine the usage of variables and functions within the class. There are mainly three types of access specifiers: private, protected, and public, but we mainly discuss private and public. Under private access specifier, the functions and variables used can only be accessed within the class and not outside the class, whereas the ones that come under public can be accessed or used anywhere within the program. Then we have also used the concept of constructors, of a phenomenon called constructors, which is nothing else that is used to it is used to initialize values to variables, which is usually not possible within a class, but it is possible with the help of constructors. Then this is the rest of the program that you can see. Then we have some more concepts of OOPs. The first one is abstraction. Abstraction is the process of hiding the implementation details of an object or a function and exposing only the essential features to the user. So it's simply, if you take the example of a car's dashboard, you could see the steering wheel, the brakes, the gearboxes, etc. But you won't see how it's functioning or the wirings behind it. If you implement this same scenario in programming, that is, for example, if you take the case of iostream.h and the function libraries within it, we are just accessing it, but we don't know what's the working behind these functionalities. It's the same thing applicable for the access specifiers: private, public, and protected. And the such scenario and such phenomenon is referred to as abstraction. Then it is simply, yeah, this is what I have already said. It is implemented also using access specifiers. These are some of the benefits of abstraction: reduces complexity, enhances maintainability, encourages modularity, improves code reusability. Then what else? This is the example that I have told you, which was the real world analogy. Then encapsulation is nothing but it's just the process of bundling data and creating a class, or simply the phenomenon or the process of the creation of class is referred to as encapsulation. um, and its key features are data hiding with the help of access specifiers, improves security, promotes modularity. Then we have an example program for encapsulation, which is given here, that is used to find the area of a rectangle with the help of a class named rectangle. And we have two private data members and public data members in the form of member functions. Then yeah, this is the example program that we have here. Then we have the next concept, which is inheritance. Inheritance is a fundamental concept. It's simply the concept that allows a particular class to use that permits the usage of data elements, or elements or attributes like um, what properties and behaviors from another class. It promotes code reuse, hierarchical classification, and polymorphism. I'll tell you what polymorphism is. So yeah, that's the next concept, which is polymorphism. Polymorphism is one of the key principles of OOP. It is written with different data types, but it is only known of which data type at the time of the compilation. And it is mainly it is a small concept, so it is mainly classified into two types: compile time polymorphism and runtime polymorphism. It has two other names as well. Then mainly we are coming to the conclusion of what it is. We have discussed in the presentation, we have discussed about what a function is, what the brief introduction, what a function is, several types of functions on the basis of several categories, and the key features of functions when we have discussed certain programs. Then we came to the concept of OOPs and discussed the concepts of abstraction, encapsulation, then what is inheritance, polymorphism, along with its features and features, examples, and the the finally the program. So yeah, thank you for listening to me, and yeah, thank you.